Over the past 3 decades, 3D printing has established itself as a versatile and flexible tool in the manufacturing toolbox. As a relatively new technology, it has spent much of that time somewhat apart, isolated from the conventional production process. But in recent years, the wall between conventional manufacturing and 3D printing has started to disappear. We are beginning to see these two separate worlds come together, and the implications of this are huge. Each year, Materialise presents the 3D printing trends that will shape our industry in the coming year. For 2023, these trends hold the key to breaking down the barriers that are still associated with adopting the technology as part of an industrial manufacturing process. Addressing these topics will help companies scale up their 3D printing operations into volume production and advance the overall adoption of 3D printing.
Traditionally, manufacturing has always centered on a single location, usually a factory overseas. And that system worked well, until it didn't. In the last few years, we've seen the crisis cripple factories and disrupt supply chains. We've seen the rise of geopolitical tensions and, of course, as well, the increased environmental concerns. All of this together has made manufacturing companies rethink their centralized production model. And with smart, digital technologies, like for example 3D printing, manufacturers can make the shift to operating through multiple smaller scale production sites that sit closer to their customers. However, many of the recent success stories have come from quick thinking in the face of short-term need, like turning to existing local 3D printing lines to produce emergency medical supplies. So you could say 3D printing was used in a more reactive way, as a temporary replacement. But luckily, these solutions, they did spark new conversations about the future of manufacturing. And we can now see that many companies are ready to adopt a more strategic approach. These companies will need to carefully consider which applications that will provide most value in terms of supply chain efficiency or environmental sustainability. And that requires a change in mindset, a shift from short-term solutions towards using 3D printing as a sustainable production method of certified end-use parts. You can take the example of CNH, an agricultural machinery company. During the pandemic, CNH relied on 3D printing to produce a vital part that they couldn't source due to shipping restrictions. They took those learnings, and now the company is taking a more strategic look at how 3D printing can help manage its supply chains in a more cost-efficient way. So the potential is real. Even in the highly regulated and certified medical industry, we see that hospitals are increasingly turning to 3D printing to produce medical models, to produce personalized implants at the point of care, so closer to the patient. You could say that's the medical equivalent of a decentralized industrial production model. In the end, smart, distributed manufacturing that is enabled by 3D printing and when done in a strategic way, can be a successful recipe in its own right, rather than an ad hoc response to problems with global supply chains.
The story of 3D printing is a story of added value. 3D printing enables design optimizations that provide performance, weight saving, time, and supply chain benefits that are impossible to achieve with traditional manufacturing methods. In many cases, these benefits create cost advantages that impact the overall end-to-end manufacturing cost, from design to delivery. In fact, a recent survey shows that the ability to reduce the overall manufacturing cost is cited as the most important benefit of 3D printing. But that doesn't necessarily mean that the 3D printing process itself is cost efficient. And increasing material and energy prices have only driven up the costs even more. Several factors determine the cost of 3D printing parts, including the materials required, production time per part, and the type of printer. There are two really important ways to reduce this. The first is by working more efficiently to increase production capacity. Software plays a major role in this by making it possible to optimize the build. We can also tune the printing process to make it more efficient and repeatable. The second is using tools that improve quality. And quality comes at a cost. Looking at certified manufacturing in the medical or aeronautics industry, for example, we see that up to 70% of the production cost is in quality control. 3D printing continues to transform the factory floor as companies increasingly turn to the technology for large-scale production. But to accelerate this adoption, our industry will have to make extra efforts to reduce the cost of 3D printing.
"3D printing is a digital manufacturing technology, but it still requires a significant amount of human intervention, and these skilled workers are increasingly hard to find. In fact, a recent survey by Materialise indicated that recruiting a workforce with the necessary expertise is the top challenge for companies that are already using or considering 3D printing. At the same time, scaling up industrial 3D printing production into the thousands or millions requires a repeatable and consistent printing process. These two challenges increase the need for automation. In recent years, software has allowed us to automate various stages of the 3D printing process, from preparing and fixing files to generating support structures, optimizing the stacking of objects into a build, or even post-processing. But these are all individual processes. In 3D printing, these different processes follow one another, coming together to create a complete digital manufacturing process. The promise of large-scale industrial 3D printing requires us to automate not only each individual process, but also the flow between them, and this is what we call workflow automation. We see the same requirement in the medical industry, where workflow automation is needed to address the dramatic increase of customized 3D printed solutions. The good news is that the ability to meet this need is growing, thanks to the creation of software platforms that allow manufacturers to define their own unique 3D printing process. Several companies, including Materialise, now offer these solutions to customers, allowing them to automate not just the individual 3D printing processes, but the entire 3D printing workflow, from order intake to delivery and everything in between.
We already talked about the important trend of distributed manufacturing. Smart, digital production technologies, like 3D printing, enable a shift towards multiple, smaller-scale manufacturing sites that are closer to the customers. A clear sign that the factory of the future will not be a single central location. This new digital distributed production environment revolves around one key asset: data. And that data needs to be secured, preventing a rogue supplier from stealing a design and printing it on his own 3D printer. Of course, data security is important in any form of manufacturing, whether traditional or smart. In both cases, companies share their unique designs with contractors and suppliers, and they want to know that their design data remain secure. But with 3D printing, there's more to it than that. Manufacturers that plan to scale up the production of a 3D printed part into the thousands or even millions need to optimize and fine-tune their unique printing process to make it efficient, reliable, and repeatable across multiple production sites. A smart production process ensures that all 3D printed components have the same quality no matter where they are produced. Creating such a process is complex and time-consuming, but it allows companies to leap ahead of the competition. That's why, in addition to data security, data integrity, meaning the close and secure link between the design on the one hand and the production parameters on the other hand, is becoming top of mind for companies that embrace digital manufacturing.